This video documents the creation of an object tracking camera. The camera detects the aruco marker shown on my phone and uses 2 servo motors to align its line of sight onto this object. The goal of this project was to practice putting together a mechatronic system, combining mechanical design, electronic wiring, and computer vision. In this project, I used a Raspberry Pi. This microcontroller took inputs from a camera module. It handled computer vision computations and sent signals to 2 servo motors connected. This is the initial video taken on the 5 megapixel camera module. One thing to note is that the frame rate is quite low. This put a limitation on the project, and from this point forward, I took great consideration to reduce the computation that the Raspberry Pi would have to handle. This is the initial detection of the aruco marker. The video on the right shows the detection of the square pattern, and the output on the left shows that we can extract the position of this pattern. This is the servo motor. This will be used to control the line of sight of the camera in one plane. Next, I set about designing the connector part. This part will connect the servo motor here on the left to the camera shown on the right there. And as you can see, I'm taking down measurements of the key features. At this point, I started the 3D design. The focus on this part was carefully transferring the sketch from a first drawing. I knew what size screws I was using, so there was emphasis on having enough support for these holes. Also, I imagined the camera in relation to this part and visualized any parts that could collide, and that's why I designed these 2 new holes. The last part of this design is preparing for 3D printing, and I sliced this part on Ultimaker Cura. I then did a test print, and there was a fault in the corner of the bed, but since I'm printing a small piece in the center of the bed, I decided that it was not a big problem. Here is the part after half an hour. As you can see, it peels right off. This is the connection to the servo motor. This is the connection to the camera. As we control the servo motor and it turns, we can control the line of sight of the camera. If you can see on the back, you'll see why I added those 2 holes for these 2 screws to have space. To explain the tracking, imagine this box is the image taken from the camera. This green box represents the aruco marker, and the blue dot in the middle represents its position. At each frame, we calculate the position relative to the camera's line of sight, and there is an error associated with that. We then aim to minimize this error by sending instructions to the servo motor to close the gap. And this is the initial function of the camera. As you can see, the camera does successfully track the marker on my phone. One thing to note here, as we zoom into the camera, the servo actually jitters quite a bit. This is a common problem which is easily solved in the software. Next, I connected 2 servo motors. With 2 motors, we can control the line of sight of the camera in 3 dimensions. Next, I sketched a new part. This part will use the second motor to control the position of the first motor. Focus was on measuring the physical parts precisely and transferring this to the SOLIDWORKS model. The last part to design is a connection from the Raspberry Pi to the second servo. The procedure here is the same, starting with measurements and an initial sketch, and then modeling in SOLIDWORKS, and then finally slicing and 3D printing. So, this is the state of the project so far. The camera can successfully track the aruco marker, and as you can see, the servo jittering was fixed, and we can track the aruco marker in 3 dimensions. Some thoughts for the future of this project. The unbalanced weight of the moving servo did cause unnecessary grinding on the fixed motor. To minimize this, I would modify the position of the servos so that the moving servo is in line with the turning axis of the fixed servo. Additionally, the speed of detection is limited. My intuition says this is caused by the Raspberry Pi and the limited computational power, but it's entirely possible that the code can be improved to increase the performance of the detection. Lastly, the modular design of the code allows any detection method to be used. This means not just aruco markers, we can use color detection, we can use object detection using convolutional neural networks.